For this question, we want to find the exact length for this curve. So let's use the arc length formula. So from the lecture, we know that the arc length L is equal to the interval from A to B, and the square root of 1 plus dy dx square, and then dx. Given that the f prime is continuous on the closed interval AB. So let's try to find the stuff under the square root first, and then we'll take the integral of that. So to find the y dx, I have to solve for y from the given equation. So if you divide both sides by 36, then y squared will be 1 over 36 x squared minus 4 to the third power. And then I want to find the y, and given the fact that y is bigger than or equal to 0, so we can take the square root of that. 1 over 36 becomes 1 over 6, and then the other terms will be 3/2 because we take the square root. Now we can find the y dx from this step, and you can apply the power rule. I'm going to bring down the 3/2, so 1 over 6 times 3/2, and then subtract 1 to the exponent. So 3/2 minus 1 is 1/2. And then we also multiply by the chain rule of the inside function, x squared minus 4. To take that derivative, we use the power rule, so we'll get 2x. And now let's simplify the entire expression. This is going to be 1/2. Because I also take number 2 right here, cancel with this number 2, and then 3 over 6 is 1/2. And I'll bring the x to the front, and then x squared minus 4 to the 1/2 power. And then now I want to find the expression for 1 plus dy dx squared. So we can do that maybe down here, 1 plus dy dx squared, 1 plus this entire term right here square. So when I square that, the 1, I'll just get the 1/2 to become 1/4, right? 1/4. And then the x become x squared, and then the other factor, we have the 1/2 power. So when you square that, you get a power of 1. And then of course you can make the distribution to the second term. So 1 plus 1 over 4x to the 4 power when I multiply this in, and then when I multiply the second terms, I'll get minus x squared. So 1 plus 1 over 4x to the 4 power minus x squared. And at this step, I can actually factor 1 over 4. I can do that. Then the x to the 4 power will stay by itself, and I'll multiply by 4 to x squared. So when I multiply it back, I'll get only x squared terms only. And for number 1, I will get 4. So when I make the distribution of 1 over 4 back to 4, I'll get back number 1. And you actually can reduce this part right here into the x squared minus 2 to the second power. You remember the formula a minus b squared, right? A minus b squared will be a squared minus 2 times ab plus b squared. So this is the perfect square trinomial. So I can reduce that into the x squared minus 2 everything square. And at this steps, I can put everything together. 1/4 becomes 1/2, and then x squared minus 2. And so now everything is raised to the power of 2. The reason I need that because when I go back to the arc length formula, I know that I'm going from x from 4 to 9, and then I have the 1 plus dy dx squared, which is this part right here, and I have 1/2 x squared minus 2, and then everything square. And when you have everything square, and then it's under the square root, so they will be cancel out, right? So you get only the 1/2, and then x squared minus 2, and it's just dx. And at this step, it's very simple. We will keep the 1/2 outside, and then I'll use the power rule on x squared. So I have x 3 over 3 minus 2. When I take the integral of 2, that becomes 2x. And then now we still go from 4 to 9. And now it's time to evaluate the two endpoints. So I'll keep the 1/2 outside, and then number 9 comes to the x minus 2 times 9, and then we will minus, and then I'll plug in number 4. 4 to the third power over 3 minus 2 times 4, and that should be everything. And if you use a calculator to do all the calculation, you should be able to get 635 over 6 for the final answer, and that is the arc length of this function, the curve from 4 to 9. For this question, we would like to find the length of the arc of the curve from point P to point Q of this function. This is actually the parabola 1/2 x squared. So we will apply the arc length formula again, which is the integral from a to b, and the square root of 1 plus dy dx square. So normally we would like to find the value under the square root, and we know that the y equals to 1/2 x squared. This is actually very simple function, which you can then take the dy dx using the power rule. So bring down a 2, so you get only the x only. And now you can find the 1 plus dy dx square, which is 1 plus x square. A very simple calculation. And then let's go back to over here. Now we know that the point P and Q, they have the same y value, and it's actually has the opposite value of the x, minus 7 to 7. So they are symmetric in this case. So we're gonna go from minus 7 to 7, and then all the stuff under the square root is 1 plus x squared. So 1 plus x squared dx. Now, because of the symmetry, right, you can actually reduce the integral from 0 to 7 and actually double the amount, because we use the property of the integral. And then we have 1 plus x squared dx. And yeah, at this step, you can take the integral by a couple of ways. But for this example, I am going to show you how you can take the integral by using the table of iterations. If you go back to your section 7.6, look at the table, and something like this will help. The integral of x squared plus or minus a squared. In this case, our a is just number 1. So if you compare to this formula, right, then the answer should just be 1/2 x, and then the x squared, and we have the plus, so it should be plus. A in this case just 1, and then we also plus again 1/2. A again is just 1, so 1 square, and then ln of x plus x squared plus 1. So that should be the answer for this problem. So let me just write it down over here again. So it's going to be 1/2 x square root of x squared plus 1 and plus 1/2 ln function and x plus the square root of x squared plus 1. Okay. All right. And then we will go from 0 to 7. And you will have to plug in 7. So I have 1/2 times x times 7 now. And 7 squared plus 1 plus 1/2 ln of 7 plus 7 squared plus 1. And then do the minus. So I'm gonna put another bracket outside. And then plug in the 0. So when you plug in the 0, you will actually get 1/2 times 0, and then 0 squared plus 1 plus 1/2 ln of 0 plus 0 squared plus 1. And then from here, we know that 0 times anything is 0. And this part right here, you will eventually get the square root of 1. So ln of 1 is just 0. So this entire term is also 0. So at the end, you will get, if I bring the 2 inside here and here, then I will eliminate the 1/2. So I get 7. And then the square root of 7 squared 49 plus 1 is 50. And then plus ln only because I multiply the 2 outside. Right? And then I get 7 plus square root of 50. And that's it. That should be my final answer for the arc length of this curve from point B to point Q.